everyone, welcome to starr-omop tutorials. My name is Priya Desai and I'm the Research and Development Manager for Biomedical Informatics here at Research ID at Stanford Medicine. This is part 4 of tutorial 2. In this video, we will try to understand the significance of a concept in the OMOP standard data model, and we're going to spend a lot of time really understanding and exploring the concept table. The way we're going to go about doing this is actually just assuming the pretext of a study. This is just to give you context as to why we're picking the conditions, the drugs that we are. So the study we are trying to sort of emulate is this study which was done in like 2013, comparing the effects of warfarin versus dabigatran with on this post-marketing report of upper gastrointestinal bleeding in new users of dabigatran versus users of warfarin. So the pretext of the study essentially is that people who have atrial fibrillation, so that's a condition of the heart where the upper chamber is arrhythmic, and that can often cause the blood to be turbulent and churn, so it doesn't flow smoothly, and this turbulence and churn can cause the blood to coagulate and cause thrombosis. So basically you could get a blood clot that could travel through your bloodstream into your heart or brain or whatever. And so these patients are often given a blood thinner. So the blood thinner that used to be has been very popular for a long time is warfarin. It's actually rat poison, but it works really well as a blood thinner. The main downside of warfarin is that it has to be titrated really carefully. So you have to be really careful and make sure that each person is getting the right dose, for their body weight and all of that. So you can't just give somebody a dose of so many milligrams and just say, okay, take one a day and you're good to go, and I'll see you in a month. But then soon after, when dabigatran, which is another antithrombotic medicine which came to the market, promised that you don't need to titrate it so specifically like warfarin. You could just have a pill a day, once a day, and you're good to go. People were really excited. And this study is trying to, look into these complaints post-marketing, so maybe a year after dabigatran had been on the market, of these reports that actually dabigatran was causing upper gastrointestinal bleeding, which is not, you don't want that side effect. So this paper was really this study was really trying to just explore how many people were getting, how many users of dabigatran were getting gastrointestinal bleeding versus how many users of warfarin per 100,000 users were getting gastrointestinal bleeding with warfarin. So that's the pretext of the study, and so that's why we've picked the drugs and the conditions and the symptoms that we have for the rest of this tutorial. So we will be talking a lot about atrial fibrillation. We'll be talking about gastrointestinal bleeding. Atrial fibrillation is a condition. Gastrointestinal bleeding is also a condition. It's a symptom. Warfarin, dabigatran, clopidogrel, these are all antithrombotic medications. So in OMOP, everything is a concept, and everything has a concept. So cardiovascular is a concept. Bleeding is a concept. The drug dabigatran is a concept. My index finger is a concept. So you can really think of concepts as almost as building blocks of the OMOP vocabulary. And there is one reference table for all these concepts, and it's called the concept table. So the way to think of it is all the different vocabularies. So for example, while we're talking about conditions, many of you may be familiar, you often have conditions in our hospitals referenced in either ICD-9 or ICD-10 codes. In, say, the UK, it may be READ codes. Somewhere it may be SEAL codes. So all these different vocabularies are put into the concept reference table so that they are all in the same representation. And I'm going to show you in a minute what that looks like. So, but the thing to remember is that they are not at the source. So, when we initially download all these different vocabularies, ICD-9, for example, sometimes they have a dot, in those numbers, in the alphanumeric numbers, in the alphanumeric numerals. Sometimes the LOINC code, for example, which is often used to represent lab values. When you download the LOINC code CSV files, you'll find that the LOINC codes are actually often called LOINC numbers. So it's completely idiosyncratic. So these vocabularies are often idiosyncratic. They're not even consistent within each other, and they're definitely not consistent between each other. And what we're trying to do is we want to really harmonize them and standardize them. So how are you going to do that? So you do that in a couple of steps. So the first step is you put them all in one reference table in the same representation. So the concept table essentially has all the vocabularies stacked up one on top of the other in one table. The second thing that you do is that you decide that one vocabulary is more equal than the others. And when I mean you decide, I don't mean you or me. The consortium, there are these groups in the consortium. The ODC consortium decides which one will be the standard reference vocabulary for a particular domain. So for example, for the condition domain, the standard vocabulary chosen is SNOMED. So the standard vocabulary is the vocabulary that is, allowed to represent the meaning of all concepts in that domain. It's the one that's been picked to be more equal than the others. So for example, there may be atrial fibrillation, there is atrial fibrillation in ICD-9, there's atrial fibrillation in ICD-10, there's atrial fibrillation in the READ code. All of these are mapped into the standard vocabulary. And the cool thing is ODC gives you the mapping, so you don't really have to go and do the mapping, but mapping, and this mapping is part of the concept table. It is important for you to understand how to do that mapping, because remember, if you're familiar with your source code, you're thinking in terms of the source code, but your data is always going to be represented in the standard vocabulary. So the one thing I forgot to mention is that for this tutorial, we're actually going to use the starr-omop 1% lite dataset, which is there in the STAR training GCP project. And if you remember, the starr-omop 1% lite dataset is the actual Stanford OMOP dataset, or the Stanford EHR data in the OMOP data format. And we've taken a random 1% of it and imported it into this GCP project, and that's what we're going to use. If you remember, 1% lite dataset means essentially that there are no clinical notes, the note NLP table and the note table is not populated. Okay. So we're also going to explore the concept table via the Jupyter Notebooks, from our laptop. So I'm going to take a second to just get set up for that. So for all of you as well, go ahead. Remember, I think in tutorial 1, I walked you through how you could actually open, the Jupyter Notebooks on your laptop, either by using a Docker container or using an installation of Jupyter Notebooks on your laptop, and you should have downloaded a Google SDK. So I'm going to go with one of the methods. I think I'm going to just do, I'm going to go with, the Google Notebook on my laptop. So in order to do that, I need to open a terminal. So I'm gonna just get set up. So to get set up, let's open a couple of tabs that would be useful. So one is, remember the GitLab where all the master notebooks live, the sample notebooks. So it's code.stanford.edu. You all should have access to it. Make your way to Nero Star Notebooks, go into Notebooks, tutorials, and for today's tutorial we're actually going to use this notebook, Tutorial2 Standard Vocabularies. So go ahead and open it. And if you remember from last time, the way we actually you want to use this most latest version of the notebook. If you have Git installed and you had cloned this entire this entire directory or repository, go ahead, do a Git pull so you get the latest notebooks. For the others, feel free to use this other method where you just manually download the notebook and then move it into your into the folder where you're actually planning to keep all your tutorial material. So for me, I remember that I actually had a Nero Star Notebooks directory, so I'm just gonna go there and okay, and from last time, from tutorial 1, you can see I have this tutorial 1 directory here. So for this tutorial, I'm going to go ahead, I'm going to download this notebook here. Then I want to move this notebook, it's in my downloads folder. I want to move this notebook, I'll use the Finder, or I'll just do it in the command line. I want to move this notebook from the downloads folder into this folder. So let's just do a move. Let's go with notebooks, standard vocabularies, and I want to move it here. And now I want to go ahead and open Jupyter Notebooks on the command line. And it's opening in this directory, so you can see that I'm in my Nero Star directory notebook, and I can see both of my files, my Python notebooks here. So I'm going to go ahead and open this notebook. This is the tutorial 2 notebook. Okay, let's see if it looks like the notebook was uploaded with as if some of the cells had been run, definitely go ahead, hit kernel, and just do a restart and clear output. I'm gonna go ahead and open this, and okay, so now I'm ready to explore this, explore the concept table by the Jupyter Notebook. But at the same time, I want to also just, for those of you who for whatever reason haven't got your notebook installed or any of that stuff, you should still be able to follow along using the BigQuery Console. We really recommend that once you're on Nero, so right now you're still on your local laptop. Once you're on Nero, you should not do that. You may not be able to do that. But this is just for me. This is just me trying to convince you that everything you can do from your BigQuery Console is indeed something you can do from the Jupyter Notebook. So I'm going to go ahead and open the BigQuery Console. So if you remember, to open the BigQuery Console, you need to be logged in with your Stanford SUNET, and you want to make your way to the the STAR training project. In the STAR training project, go to BigQuery, and in the SOM RIT STAR training project, you should be able to see, you know, for tutorial 1, we were using the SynPuff dataset. For tutorial 2, we are going to be using the starr-omop CDM5 deid 1% lite dataset. Yeah, it has a date 2019-10-24. So we actually just have a 1% dataset that was generated on 10-24. It doesn't really matter. It's good enough for what we're trying to do in this tutorial. If you just click on it, you can go ahead and see it has the same tables that the SynPuff dataset had, except now, or in this one, the persons that you're looking at, these are actually, you know, this is data, this is real Stanford de-identified data. This is, you know, these are Stanford patients, but de-identified, of course. All right, so let's get started. Going back to my notebook. Let's just make sure that we, you know, our credentials are working and all of that. So again, for those of you who want to do this not via Jupyter Notebook, but maybe, I mean, not via Jupyter Notebook installed on your machine, but via the Docker container, remember, just like last time, we have both the cells in here. So if you're using a Jupyter Notebook installed on your local computer, you know, you can use this cell. If you're using the Docker container, use this cell and comment out the other one. So I'm going to go ahead and run this. The important thing to remember here is make sure that your path name here points to your default credentials JSON file. So it should be, if you're using a Mac, it'll be /users/your SUNET ID in this config directory. Okay, since I'm not using the Docker container, I have already, you know, it's already been commented out. If it's not been commented out in your notebook, go ahead and comment it out, just so that you don't accidentally run it. Because if you run it, it's going to give you an error. That's all. Nothing's going to break. Okay, and then if you remember, we actually had parameterized our project ID and dataset ID just so that we know how to type all of this up. So let's just go ahead and do that. And for this tutorial, we're actually going to generate a few data sets. So, or we're going to generate a data set and a few tables in that data set. So each of you can go ahead and create a work data set ID. So now if I look in this BigQuery in Star Training, there are only sort of 3 data sets here. There's an operations stats, you know, folder or dataset, there's the OMOP deid lite dataset, and then there's the SynPuff dataset. There is nothing else. So I want to create a dataset for myself, where I'm going to put in tables that I create. Similarly, you should create datasets for yourself, and we'll see them right here. So go ahead and I'm going to call my work dataset Tutorial2_Priya. So let's go ahead and run this cell. So that data set should be created. So let's come back here. I don't see it yet, but I need to refresh. Look in here, and there you can see Tutorial2_Priya. So this is the data set that I've created. This is where I'm going to put in the tables that I generate as part of this tutorial. Okay. Just out of curiosity, remember that was the SynPuff dataset. I'm telling you this is the Stanford dataset. Let's just see how many patients there are in this dataset. So let's just do that. Okay. So this is just a print query, so it's really just telling you, you know, printing it in the correct format. So for those of you who don't have this Jupyter Notebook, if you cut and paste this, you can cut and paste this right here in this BigQuery, and you can run it, and you will get this output. So yes, we have 26,629 patients in the starr-omop deid lite dataset, but I can run it in the notebook itself. So this is the query, and I'm going to go ahead and run the query, transform the query to a data frame, and you can see I get the same count. It's the same query. Okay, so this was just to convince you that whatever I do here, I can actually do on the console, and it's the same thing. All right, so coming back to our slide deck. Okay, whoops. Okay, all content in the CDM is coded as a concept. Concepts are referred to by the concept ID. All the details of this are in the concept table. There are relationships between concepts. So for example, remember we said all atrial fibrillation in all the vocabularies was going to be mapped to the standard vocabulary, which was SNOMED. Well, that mapping relationship is actually going to exist in the concept relationship table. Turns out SNOMED has an amazing, is an amazing ontology. So all the relationships, the hierarchical relationships between concepts is going to be in the concept ancestor table, and we're actually going to look at the concept ancestor table in detail in the next tutorial. In the next video, I apologize. This tutorial, we're going to just focus on the concept table and the concept relationship table. So going back to the notebook, oops. So if you cut and paste this in the BigQuery table, you will get exactly this output, but we're going to do everything in the notebook. So, I know you yet don't know what is the concept ID for atrial fibrillation, but let's assume you do. Let's assume I do. So how do I know? I just know that there is this concept ID. It's 313217. I don't know what it pertains to. So if I know the concept ID, how do I find the concept? So you would just go in and, basically you're going to select star from that concept table where the concept ID is equal to this, and essentially what you get is this concept ID corresponds to atrial fibrillation, which is a condition. This concept is in the vocabulary SNOMED, and it is a standard concept. So it's a standard concept. This is its standard code. I'm going to talk about what that means in just a minute. This is the valid start date. What is the valid end date? And if it's invalid, what is the reason? The valid start date has been put to 1970 if we just assume that was the beginning of time, and if there is no plan of ending the use of this particular concept ID, the valid end date is left to 2099. The cool thing about OMOP is it doesn't forget anything. So for example, over time certain concepts leave the vocabulary, or certain new concepts are have to be created. For example, COVID-19, right? I mean, COVID-19 didn't really exist before 2018 or 2019. So that concept, the concept for COVID-19, that had to be created. So for that, you will see a start date which would be much more recent. Okay, so and we're going to talk about what exactly this concept table is telling you in more detail in just a moment. What if I actually know the code? So remember when I showed you that there was a concept ID, which is how we queried it before. There's also a concept code. What is the concept code? So the concept code is the code in the source vocabulary. So if you know what the concept code is, you could actually query using the concept code. So here I'm going to query for this concept code. And you can see that's the code. So that's the way it's referenced in the SNOMED vocabulary. The concept ID is how it's referenced in OMOP. So what's the difference between concept ID and concept codes? Concept codes come from the source data. So different source data follow different vocabularies, and concept codes are often, they may be unique within a vocabulary, but they're often not unique between vocabularies. Because the one question you could ask is, why are we giving it a new concept ID, atrial fibrillation? If in SNOMED, remember we're mapping everything to SNOMED. In SNOMED, I already have a concept code. Why can't I just use the concept code as a concept ID? Well, this is because, remember, we are piling one on top of the other into that concept table, lots of different vocabularies. So even if a vocabulary is sort of self-consistent within itself, it's not unique. A concept code may not be unique between vocabularies. And I'm going to show you what that means in just a minute. A concept ID is unique in the OMOP CDM. The other really important thing to note is the concept ID has no intrinsic meaning. Okay, it's just a number. They just went on adding, adding to the number, and the concept ID has no intrinsic meaning. So it's not like, oh, everything that starts with 31 has to do with cardiac conditions, and then 3217 somehow means more details about the cardiac condition. There is nothing like that. They're completely random, the concept IDs. Concept IDs are unique in the OMOP CDM. Concept codes may not be unique between each other. So for example, let's just see what happens if we, I think that's what I have on my slide deck. No, I have this in a minute. So let's just see what happens in this. So I am picking a concept code, a random concept code. Okay, concept code means it's the source code. It's the how that concept is represented in the source vocabulary of 1001, and you can see what happens. So 1001 means so many different things in different vocabularies. Concept code 1001 is a drug. Okay, it refers to this drug in the multum vocabulary. 1001 is a hem-onc also in the drug vocabulary. In the drug domain. In the revenue code domain, it is a standard code, but it means residential treatment psychiatric. 1001 is also a measurement in this vocabulary. It's, could be another drug in RX norm, which is a different drug vocabulary, right? You see, so it's 1001 is a drug in this vocabulary. 1001 is a different drug in this vocabulary. It is a revenue code in this vocabulary. It's a specimen in the seal vocabulary. So we can't use the 1001 code, right? So that's why you can't really use the source code as the standard. You need to map even what you use as the source vocabulary. Everything in the source vocabulary will be mapped to a concept ID. And then when you decide that this source vocabulary is my standard, then that concept ID is what is going to be considered standard. And you'll see what I mean in just a moment. So once again, just to quickly go through what's in a concept. So you get the concept ID, which is what is used in the CDM. So if you look for atrial fibrillation in the Stanford OMOP data, in the conditions table, that's the concept ID. That's what you look for. This is the English description. This is the name, atrial fibrillation. It belongs to the domain ID. So the domain ID plus concept ID combination are completely unique in OMOP. This is the vocabulary ID. So this is the source. This is the source vocabularies. This is what tells you what's the source of the data. So this is actually mapping the SNOMED atrial fibrillation to the standard concept. Okay, so the concept code. So the code in SNOMED is that, and then this is the validity of the concept. All right, so what if I know the name atrial fibrillation, then can I find the concept? And let's do that. And there you go. So if I search for the name atrial fibrillation, remember atrial fibrillation exists in ICD-9, in ICD-10, in READ, in SNOMED, in all the vocabularies. So, you know, that's your concept name, and then you look here and you say standard concept, and you say, wait, how can atrial fibrillation have two standard concepts? So remember I said it's the concept, it's unique within the, it's unique. You have to look at the domain ID with the concept ID. So this particular atrial fibrillation refers to a measured value. So the domain is a measured value. This atrial fibrillation, this is the atrial fibrillation, which is a condition. And this is the standard concept. So concept ID is the standard concept ID. So what if I don't know any of this, but I know the code in a different vocabulary? So that might be many of you who, you know, you say, well, I'm a physician. I know the ICD-9 code, or I know the ICD-10 code, but I don't know what the OMOP standard, the concept ID, standard concept ID is. And remember, I mean, the concept table has like over 5 million rows. So there's no way anyone is going to know, you know, everything in the concept table. That's not feasible. But lots of people do know the ICD-9 or 10 codes of, you know, the diseases that they might specialize in. So what if you say, hey, I know the code in another vocabulary. So maybe I know the code in ICD, you know, I know this code. I know 427.31 is atrial fibrillation. Then can I find out what is the standard concept? And you can see, yes, you can. So atrial fibrillation, this is in the vocabulary ICD-9-CM, it is mapped to this concept ID. Okay, so it's not yet been mapped to the standard concept ID. We're going to see how that happens in just a minute. But remember, you can see the 427.31 is your source code. So you see it under the concept code. This is the vocabulary ID. It is in the domain condition, and that is the concept ID. This is the reference number of atrial fibrillation of the ICD-9-CM in the concept table, or in the OMOP concept table. Okay. Okay, so the next piece that we're going to go to is, okay, sorry, before I start talking about, you know, you figured out what is the concept ID of your source, from your source vocabulary into OMOP. Now you need into the OMOP concept table. Now you need to go from that concept ID into the standard concept ID, right? So it's a two-step mapping, and we're going to do that in just a minute. But just to once again, like, you know, help clarify, think of it as all of these are source codes, right? So that condition exists in all of these. How are you going to normalize this or harmonize it? How are you going to give it a similar representation? We're mapping the atrial fibrillation of ICD-10 to SNOMED CT, of SNOMED itself to SNOMED CT, of, you know, all of these different vocabularies. And yeah, I think I already walked you guys through this. This is, you know, the difference between concept ID and concept code. For concept code 1001, you can see that, you know, it corresponds to so many different things. Okay, we did this. If you know the code in a different vocabulary. Oh, this was important. I want to point that out. In this notebook also, you can see when you're looking for atrial fibrillation and it's an ICD-9 it belongs to the ICD-9 vocabulary because the concept code is for 27.31. Under standard concept, it's going to say none. If this concept code was a SNOMED concept code, the vocabulary ID said SNOMED, then it said that it was a standard concept. So for those of you who are still confused, just hold on. I promise you this will get clearer as we complete this. Okay. All right, real quick, what are the relationships between concepts? The relationships between concepts can be found in which table? So I think I'd already mentioned that earlier in this video. Relationships between concepts can be found in both the concept relationship table and the concept ancestor table. And as I said before, we're going to talk about the concept ancestor table in the next video. Okay, so the concept relationship table. If you go ahead and run the next cell, which is this one, you're saying, so the concept ID I picked is the concept ID of atrial fibrillation in, no, what did I do? Okay, I suppose I picked a concept ID, and I'm going to look to see what is mapped to what in this concept, Okay, so to explore the concept relationship table, go ahead and run the next cell. And you can see I've just picked a concept ID 44821957 and said, in the concept relationship table, give me everything where concept ID 1 is 44821957. And you can see concept ID 44821957 maps to, or it's related to, this concept ID says this is a maps to. So these concept IDs, so is a and maps to, these are different types of relationships. The relationship that says maps to is the relationship that maps it to the standard concept ID. So this concept ID and this concept ID are related. They could be the concept IDs of maybe atrial fibrillation between maybe the ICD-9 and ICD-10, or read code and ICD-10. So these are equivalent, but they are not the standard concept ID. The standard concept ID, the way to get from this concept ID, which is the concept ID of of a certain vocabulary, in a certain vocabulary, the way to get from here to the standard concept ID is to look in the concept relationship table and look for the maps to relationship. So this is the standard concept ID because this relationship is maps to. And there is no, you don't always have to use concept ID 1 or concept ID 2. This table, the concept relationship table is symmetrical. So everything that's in concept ID 1 is also there in concept ID 2. So it doesn't matter whether I use concept ID 1 or concept ID 2. I should still get the same thing. So for example, if I just do this, just give it a couple of seconds to run. We'll talk about what subsumes means, but and so on. But mapped from and mapped to would always, that's the row which contains either mapped to or mapped from is the one that relates it to the standard concept ID. So here I've said concept ID 2 is that, and it's mapped from this, and this is the standard concept ID. Okay, so that's what I have on this slide as well. So this is this concept ID mapping to different vocabularies, and the maps to is a, and then you saw in the other, in the another query that I ran, subsumes. These are all relationship types, and we're going to talk about what they are and what they mean. Okay, so how are they all connected? So the way to think about it is this, and I think this table is was really helpful for me to understand how they are indeed connected. So the condition is atrial fibrillation across the board. It's atrial fibrillation in, let's for example take these three vocabularies: ICD-9, CM, read, and SNOMED. In ICD-9 CM, in that source vocabulary, atrial fibrillation is referred to as 427.31. In read, it's referred to as G57-3000. In SNOMED, atrial fibrillation is referred to as 494-36004. The concept ID, which is mapping this vocabulary, this concept code to the OMOP, to an OMOP concept. This concept ID is, so 427.31 is mapped to 44821957. So for this concept ID refers to atrial fibrillation in ICD-9-CM. This concept ID refers to atrial fibrillation in the read vocabulary. This concept ID in OMOP refers to atrial fibrillation in the SNOMED concept ID. Then we've decided that this SNOMED is the standard. It's the vocabulary that's more equal to everything. So these concept IDs are now going to be mapped to this, and this is going to be mapped to itself, right? So the standard concept ID for atrial fibrillation is that. So this, which is the concept ID for atrial fibrillation in ICD-9-CM, is now mapped to this. And how do you know what this mapping is? That's when you look in the concept relationship table, and the mapping has to be ISA, or it's not ISA, I'm sorry, it has to be what we looked in here. It has to be maps to or mapped from. Okay, so I hope that really helped. The way the cool thing, I think I mentioned this before, the cool thing about the OMOP data is that the data set always travels with the vocabulary, right? So the concept table is always going to travel with you. And so atrial fibrillation in ICD-9-CM has this concept code. This is the source. It's mapped to this in OMOP. SNOMED is mapped to this in OMOP. This is considered to be standard. And so then the next thing, this is mapped to this, and that's what you would, so in the condition occurrence table of your actual data set, what you're going to see is that person 123 has the condition concept ID in the standard concept, which is in the standard terminology, which is 312327. We always keep the source, the provenance is always kept. So the source value, however, is 427.31, which is where it came from, and the source concept ID, right? So remember, concept ID is in OMOP. The source concept ID is 44821957, which is what this had been mapped to in OMOP. So do you see that all of this information is kept and is there for provenance in your final data set? So in order to actually go from a concept that you, or a concept that you may know, say a diagnosis in another vocabulary, how do you go to the standard terminology? So first you find the source standard concept, right? So for example, I know that the concept code is 427.31. So let's just first look for the source concept. Okay, so that's the source concept, so concept code, and that's the mapping of the concept code into OMOP. into the OMOP concept ID. Next, I need to map this concept ID. I need to map it to what does it map to with the relationship maps to or mapped from, right? So I'm going to say in the concept relationship table, this concept ID, which I just got, so I want this concept ID and the relationship should be maps to. And so if I pull that out, you will see that this concept ID maps to this concept ID, and therefore this concept, whatever it's mapping to, is going to be the standard concept. So that's how you would find the standard concept ID. So standard concept ID for atrial fibrillation is 313217. So these are some really nice exercises for you to do, for an ICD-9 code for 27.31, that's the one we just did. The read code G57 3000, go ahead and try to find what the standard concept ID is. For the ICD-10 code, I48.0, try to find out what the concept ID is. And you can actually go ahead, try it yourself. And if you get stuck, go ahead and run these cells, because it's really been done for you here. So G57, so this is the read code. Read code maps to this concept ID, and then this concept ID maps to, let's see what it maps to. And you can see it also maps to 313217, right? Which is the standard terminology, which is atrial fibrillation in the standard terminology. Same deal with this one. Okay. All right, so it's interesting. This one has two concept IDs. Oh, okay, they're the same. Oh, I see, sorry, my bad. So here I've said where concept ID 1 is this one, or concept ID 1 is this one. So it's both of them, and they're flipped, and you can see both of them are being mapped to this. So yeah. So that's all we're going to do in this video. In the next video, we're actually going to explore relationships. So we're going to explore that relationship table more, and then we're going to also explore the ancestor table. So I'll see you guys next time. Thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.